Hello guys, I'm Dr. New. Welcome to my channel. And today I'm going to show you a very small project using the BNO055 sensor. And if you don't familiar with this sensor, you can refer to my previous short video to learn how to connect the wires and download it to the Arduino Uno R4 Wi-Fi. Okay, here is the small board, and in this board you can see there is a power source for the red board, and in the center you can see there is the AMU sensor, and on the lower side there is a EEPROM, and the left side you can see it's ESP32C3 Super Mini MCU. And also you can see there's a antenna here. Okay, and I have uploaded the code to the GitHub, so you can refer to this website for more details. And in this video, I'm going to demonstrate how to use this sensor step by step. Okay, let's go. Here I found three tabs from some Windows. And the first one you can see is the very earliest version. This one. It's a black pill. You can see there's an antenna in red color. And this is one of the earliest versions. You can find the pinout from the website. And the benefit of this board is very cheap, about $2. And the disadvantage is that it has a very insensitive antenna, so you can always encounter the signal lost and something like this. And the second type is a red pill. You can see the red pill. And different from the previous version, it has a antenna, so you can see the apex socket. So it has a better signal to receive the Wi-Fi, and it's better than the previous version, and I'm going to use that in my project. And this version. And the last one you can see is the newest version. It's a black pill, but it replaces the antenna by a white component. I can tell what it is, but I guess it is a resistor or an antenna. And it has a very powerful high gain antenna here. In this project, I'm going to use a EEPROM. So you may ask me, why would you use that? I think the reason is that for the ESP32C3 Super Mini, we don't have such EEPROM to store data. And when you power this board off, and still we have the data stored in this chip, like just like the flash. And in the RAM, if we lost power, and everything in it is lost. And I can find two types of the popular EEPROMs. So the first one is this module. So you can see we have some jumper caps. Is A0, A1, and A2. So it represents the lowest 4 bits of the address of this module. So if you set the jumpers, so you can set this connect point to 0 or 1. So you can select different address to read from. And this module is functioning uses the I2C, I2C. So you can see it also has a LED for the power supply. And the second version is a very small one. And in this version, You just connect all the A0, A1, A2 to the ground. So it has very fixed I2C address. So what's the EPROM used for in this project? And BNO055 has a calibration process, which means we should flip, move forward, upward, around in 8 for multiple times. And then finally, we got a set of parameters to calibrate this sensor. And if we just press the reset button of the MCU, then you should do it all again. It's not very convenient for us, right? So we should store the calibrated data to the EPROM, and then we can, in each restart, it will load those data into the sensor, and we don't have to calibrate once more. And this is what the EPROM is used for. But unfortunately, and for the BNO055, the magnetometer is not accurate enough. So each time we must calibrate it. But compared to nothing, it's better. So we use the EPROM. But if you're wondering, there's some others uses EPROM as a flash. So they use some space from the flash, and they took this space as the EPROM. I think it's okay, it's totally acceptable, but it will lower the life cycle of your flash. And for the flash, you can read and write about 10,000 times. But if you load this data for once, it will lose one time. So I prefer external EPROM than simulate the EPROM with a flash. And for some Arduino series chips, they have built-in EPROM. So you don't have to use an external one. It has a built-in 1 kilobytes EPROM. So to use this code from the website, first you should search for ESP32 BNO055 PyTeapotPlus. You can see the source code and README here, and download the code. Select this button, download zip. After you download this zip, we open this folder by File, Open Folder, and select the zip that the folder have downloaded. And before we download the program to the MCU, we have several set configurations to do. The first, go into config.h. So the first thing, the I2C address, use pin 3 or pin 4 or other pins. You can customize it. And you can set the sampler rate, the ODR, the output data rate, to 10 Hz or to 5 Hz by default. The next one is the I2C address of the BNO055. And in my previous short video, I set it to 28. So you can set it to 29 or 40 according to your settings. So, and each time, the sensor would calibrate itself. But if you tend to recalibrate these options into true, it will do it every time. But if you turn it off, it will only calibrate it once and store the calibration data to the EPROM. And next time we want to reset it and restart it, and we'll load the data from the EPROM into back to the sensor. So you don't have to recalibrate it again. But the next option is to skip mag calibration. And each time the magnetometer requires calibration. If you want to turn that off, you think that is annoying. So you can set it to true. But I suggest you to set it as false. Because if you set to true and skip this process, you will always receive some failure in the readings, if you are not recommended to do so. And if you use serial port to send in data from the MCU to your computer, so you set it to true. Otherwise, use the UDP is a various mode, and you can set it to false. And if you want to use quaternions from the serial port to the computer, you can set it to true. And the next option is related to the quaternions. If you are written quaternions from the serial port and you want to visualize the Euler angles, so you can set to true, otherwise you set to false. It's totally up to you. And for the UDP settings is nothing relative to the serial port settings. So you can set the name of the access point, which is the MCU on your board. You can set the BNO055 by default. If you left the password empty, so which means it's an open access point, and each device can access to it. If you are concerned about the security issues, you can set some passwords. And next, the listening port I set to 5555. Then this port should be consistent with the software on the computer. And I suggest use the default local IP and gateway and subnet. If you want to use a new IP address, you can just test it. The next part is to set up the Python script. For example, if you want to use the PyTeapotPlus.py to visualize some default shapes, and you want to visualize some 3D models in your computer, so you can use this PyTeapot.3dm to visualize it. And for each file, they have the same configurations, almost the same. And for the PyTeapotPlus, if you use serial in the config.h, so you should set use serial to true in this file. And if you use quaternions in serial port, so you should set use quat option to true in this one. And the next, you want to set up the serial port on your local computer. You can find it from this Arduino extension. I strongly recommend this extension to you all, which is the Maker Workshop Home is an extension. And in this extension, you can set up the board, and in this button, you can set up in other options. And for the ESP32 development board, you can set to CDC on boot. You can enable it. You can leave other settings as default, the same as mine, if you use the same board as mine. Okay, and here you can find the board manager to install the ESP32 boards. You want to install some libraries. You can just first you should select not installed, and you search for this library. And for this project, you should install two libraries from this. The first one is Adafruit BNO055, and the second one is an AT24C, and this library. So you should install these two libraries first. And for the profile manager, you can save some configurations for a very successful download. So if you want to reuse it, you can just set this profile and download again. And here you can find all the examples. Very convenient. And also we have some external tools, which is we are not going to use that. Okay. So, by the way, if you want to use this extension, I suggest you to install Arduino IDE on your computer first, because this extension will detect the environment variable of this installation directory and use some resources. Now, after these configurations, the next step is to download the code. So which one we should use? This one. It's BNO055 UDP mini c3.ino. And in this script, you have nothing to set. And then upload. Click with the button here. And see some informations. And the entire process is very long. It may take up to 5 or 4 minutes. Please be patient. Okay, if you are boring, get a cup of coffee. Get a sip. Oh, very good news. It started to download. Yeah, that's progress bar. I like it. When you finish downloading, you can open the serial port. Start monitoring. You can see I already calibrated it before, so I don't have to calibrate it once. So here you should calibrate magnet matter to get all those numbers stable. Okay, it's done. You can see we get very stable numbers. It's quaternions. Okay. And for the next part, we stop this serial monitor first. We should specify a Python script to execute. Okay, this one. So we can view the default shapes. And before we doing that, we should install some Python labs first. So open your Anaconda console and go to the directory of the folder, and we should activate our Pico 2 environment. Okay, so here you want to we enter this PyTeapotPlus directory, and we use pip install requirements.txt. If we run this, it will install some labs here. Yeah, I already installed all of them, so don't install again. So when this is all done, you should set the VS Code environment consistent with your Anaconda environment, with our Pico 2 here. And you should run without debugging and Python debugger script. First, we should calibrate the magnetometers. So you just roll here until it's done. So it's a long process. So be patient. Okay, it's done. So you can see this cube is moving. So the green axis is point to the positive direction of z. The red arrow point to the x direction, and the blue to the y direction. And for this absolute orientation sensor, this blue axis always point to the North Pole as the global coordinate system. And if you done some rotation, it will rotate along those axes. You can see I just made some modifications. So when I point right to the desk, it should be 0. It's the default position. And you can see this is the roll, which means we roll around the x-axis. And this is the pitch. The pitch is with the y-axis. And for the z, we have the yaw here. It just rotate. Okay. So if we close this window, you should see the FPS here. The next part, I'm going to show how to use this UDP setting. So to use the UDP settings, we should first modify something in the configurations. So first, we go to config.h, and we set those use serial port as false. So we got, remember this name of the access point, BNO055. Okay, and in the Python script, we set use serial at false. Okay, we check this address, so that's same. Okay, and so first thing, I'm going to turn on this breadboard power. So it will provide some power to this sensor, and we disconnect it. Oh, I'm sorry. we don't have to disconnect it yet. So we have to download the program first. So we go to this, okay, we upload. It may take some time, but it worth the time. Okay, it's done. So we can disconnect. Yes, sorry, it's a bit loosey. The first thing we'll connect our computer to this access point, so we can open the various settings. We search for this access, the name of this access point, which is BNO055. Okay, we have connect our computer to Wi-Fi to this access point. The next part, we switch to this Python script and run it. So you can see, and we disconnect the cable. So it's a various settings. It's a very good signal, and play the areas out everywhere. Because we use quaternions, so there is no gimbal lock, so you can rotate 90 degrees in every direction. Okay, next I'm going to show you how to use this script to visualize some 3D models from your computer, such as your DAW OBJ file. So first, we use some serial mode. So we just connect the cable connect to this sensor and MCU. We do some modifications. First, we go to the config.h. We use serial, we set to true and save it, and we switch to the YONO file and upload. Okay, there's hope. The progress bars. Okay, here it is. Okay, done. So because we are using the serial part, first we should do some, we don't do any calibrations, okay. And we switch to the teapot 3dm.py. Here we first check these settings. Make sure you get the correct address for the model, and so we run this. So we get those readings. So first we calibrate magnetometers. Okay, we got it. So when we face the desk, we will look from the top to down. So you can see the car here. So we can see the yaw. We just rotate. Rotate the direction just like steering the wheel. And then we have the pitch. So we let the car nod. We can do the roll. Let the car roll here. So there are some failures. So which indicates the sensor is not as reliable as you may expect it. Okay. Using the yaw, pitch, roll. I hope everyone can enjoy this video. So please like and subscribe. I will publish more excellent content for you to enjoy. And I'm going to show more projects to build a powerful robot. And welcome to News Robot Lab.